boost regulator is a DC-DC converter whose output voltage is always greater than the input voltage. It uses a switching element to regulate steady DC output of required voltage. I am Reshma, and today we will discuss the operation of a boost regulator in continuous mode of operation. In this video today, we will see voltage transfer function, inductor current balance method, voltage transfer function, inductor voltage balance method, and current transfer function. Let us now look at the voltage transfer function using inductor current balance method. From our previous videos, we know that when the switch is on, change in inductor current is given as Vin into D into T total divided by L. When the switch is turned off, change in inductor current is given by minus of Vout minus Vin into 1 minus D into T total divided by L. We know that in steady state condition, change in inductor current during switch turn on must be equal to change in inductor current during switch turn off. This means net change in inductor current is equal to 0 amps. Now, DIL on plus DIL off is equal to 0. Let us substitute the values of on and off current values in this. We can cancel out the common terms. After simplification, this is the equation that we get. Let us now take the negative sign inside the bracket. Now we can cancel out the common terms. If we keep input voltage on the left hand side of the equation, we get the equation as shown here. Then output voltage can be written as Vin divided by 1 minus D. Here we can observe that output voltage is dependent only on the input voltage and the duty cycle of operation. It is independent of inductor value and switching frequency. Let us now look at voltage transfer function using inductor voltage balance method. From our previous videos, we saw that when the switch is turned on, the inductor voltage is equal to the input voltage. As the switch is turned off, the inductor voltage is given as minus of Vout plus Vf minus Vin. Under ideal condition, we can consider Vf is equal to 0 volt. Then we can write voltage when the switch is turned off is given as minus of Vout minus Vin. We know that in steady state condition, average voltage across the inductor is 0. This means total voltage across the inductor over one cycle is equal to 0 volt. Then we can write the equation as shown here. Let us substitute the inductor on and off voltages to get this equation. We know the equation for on and off times. Let us substitute them in our previous equation. Here, T and T gets cancelled. Let us now multiply the terms to get this equation. On simplifying, we get the equation as shown here. On equating it for output voltage, we get Vout is equal to Vin divided by 1 minus D. We can see the output voltage is dependent only on the input voltage and the duty cycle of operation. It is independent of inductor value and switching frequency. Let us now look at the current transfer function. For a lossless system, we know that input power is equal to output power. Then Vin In is equal to Vout Iout. The input current is given as Iout Vout divided by Vin. Previously, we saw V out is equal to V in by 1 minus t. On substituting this in the input current equation, we get I in is equal to I out divided by 1 minus t. In this video today, we saw the voltage and current transfer function of boost regulator. We will learn more in our subsequent videos. Until then, let's keep exploring and learning. Thank you.